This is second question from a rotational motion from the book Pathfinder. Check your understanding. So this question is that we'll see to this diagram when we read through the question. The question is that free end of two inextensible strings, they are wrapped around a massive disk of radius. This is the massive disk we are seeing. Its radius is 10 root 3 centimeter and they are affixed to the ceiling. So these 2 points are affixed to the ceiling at two different points, which is obvious from the diagram. Both the chords and the disk are in same vertical plane. So everything is in same vertical plane at an instant after the disk is released. So you are holding the system and then you release this. Angles made by the chord are theta equal to, this is 67 and phi, this is 53. Angular velocity of the disk is 5. We need to find out the magnitude of velocity of center of the disk at this instant, just after system is released. So let us see how do we solve this. Again, this is a conceptual question. And based on, there are two key concepts here. First, we'll understand those concepts. One is that the component of velocity along the length of taut string. So I have missed here, let me write that. Along the length of taut string. So taut string is actually like a rod. So if it is like a rod, distance between these 2 points is fixed. So whatever velocity of this point is along the string V1, if this point has velocity along the string V2 component, then V1 equal to V2, right? So it's like a rigid rod. And then second thing is that perpendicular lines on velocity vectors meet at instantaneous axis of rotation. So suppose this is the rigid body and one point velocity, this is V1, another point velocity is, let us say, V2. Since instantaneous axis of rotation is a point about which at that instant, the entire body can be assumed to do the pure rotation, right? So this is the axis. Since the body is doing pure rotation, velocity should be along the tangent. So these are two tangents, right? If you draw perpendicular on the tangent, then perpendicular to the tangent is radius. So two radius will meet at instantaneous axis of rotation. Fine. So if you are not very familiar with this concept, then you have to learn this concept first. Once you understand this concept, then only you can understand this question, right? So after that, it's very easy. I have drawn this diagram. So this is a disk, right? Now, see, this is the string, right? And this end of the string is fixed. If this end of the string is fixed, then this end can have how much velocity? 0 along the string, right? Because this is 0, this is also 0. Likewise, same logic, the velocity in this direction will be 0 because this end is fixed. V1 equal to V2, V2 0, V1 0. So then now this can have velocity only along this. So this is one direction, it can be other way around also. It has to be perfect, and this is another velocity direction. Fine. Then what we have studied, if we draw perpendicular on velocity vectors, they meet at instantaneous axis of rotation. So O here is instantaneous axis of rotation. Fine. So now 90% of the question is solved. Just that now, just some distances we have to find out, and we can use V equal to R omega about instantaneous axis of rotation. So you can now say that at this instant, the entire disk is doing pure rotation about this axis. And velocity of any point you can find out just by doing R omega. So we have to find velocity of center of the disk. We have to just find this distance, omega we know, right? Now you can see finding this distance is very easy because this is tangent, this is also tangent. So from symmetry now, so this is 67, 53 makes this angle as 60. So let me mark this here. This angle is 60. So if this is 60, then this remaining angle becomes 120. From symmetry, this smaller angle becomes 60. This also becomes 60. Fine, you can see that. So if this is 60, this is 90 because tangent and radius makes this as 30. That's it. This 60 is enough to calculate this, right? So this is, consider this right angle triangle OAB. O is instantaneous axis of rotation. If you have understood, you can solve this by yourself also. It's very easy now after this. So triangle OAB, in this OB, this is OB, right? This is what we need to find out. OB sine 60, this is cos 60, this is sine 60, is actually the radius. So OB sine 60 is radius. Radius is 10 root 3. So sine 60 I have put and then found OB. Then since this is instantaneous axis of rotation, the entire each and every point of the body is doing pure rotation about this axis, V equal to R omega, right? What is R? This is R. And this V now is the V which I am calculating is this. So this is r into omega 1 meter per second, right? So that's it. If we understand instantaneous axis of rotation, again, this becomes easy. Otherwise, in general, if you ask me, it is a tough question, and it is highly probable this similar type of question can come in JEE Advanced. So thank you. Thank you very much for watching. If you have liked my analysis, please like this video and please subscribe to this channel also. Thank you. We'll meet again.